sorry, we skipped a little bit. I forgot to record. But any ray of light that is parallel to the principal axis goes through or emerges from the focal point. All right, so we have drawn a concave mirror with principal axis, center of curvature, vertex, and focal point. So we're now going to use this rule to draw one of our rays. All right, we have a ray that is parallel to the principal axis. So we'll draw two. You can draw more if you like, if you have a bigger mirror setup. But these are incident rays. And you can see that they're parallel to the principal axis. Is that okay? Now the rule states that they are going to reflect so that they go through the focal point. Reflected ray. Reflected ray. Okay, so the first rule is very generally all the lights are off, so you may not be able to see it anywhere. So if it comes, okay, this sign means parallel. I'm drawing two parallel lines and writing EL. That's like the short form for parallel, in case you were wondering what that is. I like short forms. Short forms are always fun. So I'm going to put that in here too. Those are two parallel lines, and then EL for parallel. Okay? So the first one is coming in parallel to principal axis, and it goes through the focal point. So how does this translate to a convex mirror? Again, we are going to draw mostly the same thing. All right, we have our vertex, principal axis. We have our center of curvature on this side, and our focal point also on the other side of the mirror. Notice that I've drawn that on the opposite side, on the shaded side of the mirror, even though this is the reflective surface here. Okay, so again, I'm going to have rays of light that are parallel to the principal axis. Same idea. And this is what I mean emerges from the focal point. What that means is I'm going to put my ruler as if I'm going to draw it through the focal point, and then just draw, whoops, it's not straight. This bit, so that if I extend it backwards, it does pass through the focal point. Does that make sense? The same thing over here. I'm going to put it like I'm going to go through the focal point, but I'm not. I'm going to go the other way. So one side's for a convex, one side's for a concave. This is the convex. This is the concave. Is that okay? Okay, we're going to now draw the same two mirrors below to draw our second rule. Okay, rule number 2. So any ray of light aimed at the focal point or passing through the focal point reflects off the mirror parallel to the principal axis. So this is just more or less essentially the opposite of the first rule. Right? This is rule number 1. Rule number 2. Incident ray is through the focal point or at the focal point. It's better. But it always comes out parallel to principal axis. Alright, so let's see what we mean by that. We're going to aim a ray of light that's passing through the focal point. So now this time the incident ray is going through the focal point. Right? Do you see the difference between what we drew up here? The incident ray was coming parallel to the principal axis. Here the incident ray is passing through the focal point, like this. And once it hits the mirror, it bounces off parallel to the principal axis. So you can draw another one that's going down. This bounces off parallel to the principal axis. Okay, so the diagrams look almost the same, but the key thing you have to note is the difference in arrows. So first one, the parallel one was coming in, and through the focal point was after it was reflected. Here's the opposite. We're going in, passing through the focal point, and then after it's reflected, it's emerging parallel to the principal axis. So these are the opposite diagrams, but they look the same. Just the arrows are different. You'll know. Okay, the same thing over here, but even this looks a bit different, right? Because let's say we have an object that's aimed at the focal point. So it's not going to get to the focal point because it can't. That's on the wrong side of the mirror. We're just going to aim it at the focal point like this. I will allow time to write to the second rule. Yes? Yes. Any ray of light aimed at the focal point reflects off the mirror parallel to the principal axis. Okay, so we're going to aim it at the focal point, but we can't actually reach the focal point because it's on the wrong side of the mirror. And we're going to reflect this parallel to the principal axis. Again, on the bottom we can try. Aimed at the focal point, right? But it reflects parallel to the principal axis. So again, you will compare the two diagrams. They're basically opposites of each other in the sense that they look exactly the same, but the only difference is the direction of the arrows, right? In which way the arrows are going. The arrows are all opposite because the incident ray and the reflected ray have been flipped because of our two rules. Okay. At this point, we have two more rules to cover. So if you don't have any space, you're going to go back to this page where I say optical illusions with plane mirrors, and I've left you a bunch of space. We will cover this at some point during like a fun class, but you can continue your work on this page. You can just scratch off the top for now. I'll give you a new worksheet with that heading later on. Is that okay? So I'm going to continue on this page, just for fun. If you have room, you can just continue there. Yeah, I think so. Depends on how big you write. If drawing the mirrors seems painful now, don't worry. I will provide you all mirrors in the future. We're just going to draw it for this one time. Okay? Now, third rule. These are the big three rules. The last one is like, it's a rule, but it's like more or less like very annoying, so usually people don't use it. But the first two rules are the most common rules that are used. Those are the important ones. Alright? And we will remember, even from drawing our ray diagrams for plane mirrors, that we need two light rays to converge on a point, right? So if you use these two rules, you have two light rays. So technically, you just need to know these two, and you'll be fine. Alright? These are just more rules, because sometimes it's easier to use some of these rules. So this is, I'm going to write a bit bigger. There we go. Okay, I think hopefully that's better. Any ray of light passing through or aimed at C, C is the center of curvature, is reflected back on itself. What's the what? Through the focal point or at the focal point. And we'll make a table later, don't worry. Okay, what is this rule basically saying? It's saying that if my ray of light is going through the center of curvature, so you see this is my incident ray that goes through the center of curvature, I'm going to basically reflect that back on itself. Very easy. That's all you got to draw. That's the same reflected ray. This is like our example where the plane mirror, we had a plane mirror and we had an incident ray of light that was along the normal. Remember that, where it was reflected back on itself? This is the same idea. If the ray of light is along the center of curvature, that means at the point of contact, that's the normal that you're drawing. So the normal is technically here. Angle of incidence is 0, angle of reflection is 0, that's why it's reflected back on itself. We can draw one more, just like this, going in, reflected back. Same thing for a diverging mirror, except you kind of have to aim it at the center of curvature and you can't actually reach it. If it's coming in like that, it just reflects straight back. But we know it's aimed at the center of curvature. That's why we can use this property. Same thing over here. If you aim it at the center of curvature, you can draw a ray of light that goes in and then comes right back out. Alright, so this is the third rule. Yes?
Does it matter like how you put the arrows for that rule?
Like
if you bring it in first and then make it go out.
yeah, if you mean this is like here?
Yeah.
That's fine. No, it doesn't matter. It doesn't matter where on the line the arrow is as long as there's an arrow on the line. Yes? Which lines have to be equal? Like these two lines? They're completely independent. So as long as I could have drawn one like this, I could have drawn one like over somewhere over here like this. Right? It doesn't matter. As long as the only property you're looking for is it has to be aimed at C or passing through C. That's the only important thing. Okay? Okay. Our last rule is very rarely used because it involves using a protractor. For the sake of this current thing that we're doing right now, we will, I think, forego the use of the protractor just because I told Jacob we don't need it, and I don't want to lie to Jacob. The fourth rule states that okay, just to be clear, this is not technically a rule. This is just something easy. So I'm not going to write the rule. I'm just going to say what you can use. I'm just going to say that the normal at the vertex is the principal axis. Alright, so if any ray of light vertex, you can easily do okay, basically all these rays that we've drawn so far are still following the law of reflection, right? We're just calling them rules because it's easier to learn this than sit and draw a normal every time and measure angles with a protractor every time. Right? But what this says is the normal at this vertex point is equal to the principal axis. That's the normal. So if I draw a ray of light that's aimed at the normal, what is my angle of incidence? Where is that located? What? Yes. Just like the law of reflection states. But we can easily measure that angle because we already have a normal that's drawn as our principal axis. So this is automatically angle of incidence. We can measure that easily. We don't have to draw a normal that looks weird or is not straight or at a weird angle or anything. That normal is the principal axis. So we can measure that angle easily, and we're just going to measure the same angle going out as our angle of reflection. Angle I equals angle R, right? It's the same thing that we've been doing, except it's easier to do in this case. Right? This is why it's not so much a rule, it's just an easier version of the same thing that we've been applying all the time, law of reflection. Right? And the same thing applies to this. In this case, the convex mirror looks exactly like the concave mirror. There's no difference between the two. If you want, you can use a protractor. I don't mind if you rough sketch and just write angle I equals angle R. I suspect that none of you will be using this rule because, again, it involves the use of a protractor. You will much likely favor the other three rules because they're just easier to execute on a curved mirror. Because you already know the focal point, you know how to draw a parallel ray, and then that's it. Yes, Jacob. What? If you have a protractor, you can use it to measure that exactly. But is everybody okay with the rules that we've done so far? No, these are the only 4 rules that we are going to learn. If I draw a ray of light that is random, like if I just draw a ray of light, let's say like this, all right, what I would have to do is, again, like we were saying, like you have to find this exact point, construct a normal that might not be parallel, will not be parallel to the principal axis. It will be somewhere like this. Measure angle of incidence, measure angle of reflection. We don't want to do all that. So that's why we're just using these rules to estimate, or not estimate, to tell us where the image will be formed. These are all rules that are based on the law of reflection. Any questions with this so far? Okay, I see that we have a little bit of time. So I suppose we can just continue working. Okay. Yes. Do I have a stapler? Maybe. Maybe not. Okay. How about you take a breather for like 2 minutes? Just relax. No jumping around. No monkey business. Just like, chill for a couple minutes. Good job. Thank you. I forgot to stop.